All right, so we're looking at using for loops to process two-dimensional arrays. I know you all read this section over the weekend, but it's got some good information on it. So basically the idea is when we're looking at a one-dimensional array, like you have on your note sheet in front of you, for a one-dimensional array we use a single for loop that loops over the indices inside the array. So I thought it would be a good review to start there. If I have a one-dimensional array, I use a single for loop. It starts at index 0, which is the first index. It goes up to the length, but not including the length, so I don't go out of bounds, and it counts by ones. It almost looks like the exact same thing as our string loop. Now, I did kind of goof up here. I wanted this to be a sub I. So my apologies. I think it'll still actually work the same way, but I meant for it to be a sub I. So that's usually what we do for our regular old one-dimensional array. We use a single for loop. Some of you maybe needed a little bit of help remembering how to use enhanced for loops. Here's an example of an enhanced for loop. Over here we have the type. So in this case, the type would be doubles for my array. Here I've got just a placeholder name. And then over here, I've got, after the colon, basically the name of the array. So that's how we write a enhanced for loop for a 1D array. Today we're going to kind of take these concepts and extend them so that they work for two-dimensional arrays. Now, as you read on over the weekend, I should say, it's important, first of all, to determine the length of your array. You can determine the number of rows by doing the name of the array.length. You can determine the number of columns by doing the name of the array sub some row index.length. Now, if the array is rectangular, R2D sub 0.length will give me the number of columns in every single row. If it's not rectangular, I got to do something a little bit different inside of my for loops, which we'll talk about. But you need to use both of these as control expressions or your stop expressions for your nested for loops. So you need to know these two things because your nested loops, the first one will count up to R2D.length, the second one will count up to R2D sub 0.length, essentially because we always go row, well, most of the time we go row major. So typically we do the rows first, followed by the columns second. What I have are a ton of examples of nested for loops. Down below. I know that you folks were reading this over the weekend and you saw this example. I think this 8.2.3 example is really good, so I'm going to zoom in on it. To loop over each individual row, keep in mind that a 2D array is an array of arrays. So this first loop says pull out the 0th array or the 1th array or the 2th array. Pull out the row number essentially. So this will pull out the 0th row, the 1th row, the 2th row, so on and so forth. In this case, this loop would pull out the 0th row first, and then it would pull out the 1th row second. After I pull out the 0th row, 1, 2, 3, then it says use this nested for loop to pull out a column from that row. In other words, start at index 0 inside of a row. So 1, then 2, then 3 inside of the row, and then it finishes. So what would print out in this case? Well, it would print out 1, 2, 3, then it would go back up to the top of the loop, row would get incremented to 1, and then it would print out the next set, 4, 5, 6 in this case. Down below here it says, what does the following code do? Add another row of numbers to the matrix. Will this loop traverse this row too? Down below here, let's see what we got. This looks like a loop that is going to sum up all of the elements and then find the average of those elements here. So it starts at total at 0. We get a single value by using our nested for loops, and we add that value to the total. And then to find the average, since it's a rectangular array, we can just take the length times the row's length to find the number of elements. Divide by that, it'll give us the average. If you don't believe me, you could go ahead and run it and check it out, and I'll find the average of the elements inside of this array here. I believe that's the right average. So I've got other examples on my note sheet as well, but the big idea is when you're going in row major format, like this one here, row major, meaning you do rows first, column second. You write a row loop that starts at index 0, goes up to the number of rows, if we have a two-dimensional array named matrix. Then, inside of that, you use another nested for loop to loop over the columns. And notice that the columns, I have matrix sub row dot length instead of matrix sub 0 dot length. Why might I want to do that? Yeah, Eli? Very good. If it is a ragged array, this will work. If it's a ragged array and you use matrix sub 0 dot length, it will not work because it's not guaranteed that every single row is the same length as the first row. I just always write my nested for loops like this, where it's matrix sub r, or matrix sub row, whatever you want to say, just so I'm guaranteed it works for rectangular arrays and it'll work for ragged arrays. And then just to access an individual element down here, you do matrix sub row sub call. Matrix sub row sub call. That'll give you an individual element, I guess I should write in. So the big takeaways from this first lesson that you folks read over the weekend, that's why I'm kind of going through it a little bit quicker. The big lesson is you write nested for loops. If you're looping over the rows, you should just go to matrix.length. In other words, that'll tell you the number of 1D arrays in the 2D array, aka the number of rows. Your nested for loop inside, you loop over the columns if you're doing row major format, and the columns are going to go up to matrix sub row dot length. Not just matrix dot length, but matrix sub row dot length. In other words, the number of elements in an individual row. And then to get an individual element, you have to doubly subscript sub row sub call, because it's a two-dimensional array. You need 2 dimensions to get a single element there. Any questions on that? Trying to think if there was anything else I wanted to go over in here. Nah. Oh, yes. One quick thing. Column major traversal. What do you think column major means? Well, instead of doing rows first, you loop over the columns. So let's say I have a two-dimensional array that looks something like this. 1, 2, 3, 4, 5, 6. Row major format will go 1, 2, 3 first, and then 4, 5, 6 second. Column major format would go 1, 4, 2, 5, 3, 6. So if you're asked to write a nested for loop that loops up and down over the columns instead of left to right over the rows, how can you do that? Well, first of all, you need to make sure it's rectangular. You can really only do this if it's a rectangular 2D array. And then essentially you just switch the 2 loops. Notice these 2 loops are essentially switched. Instead of doing the row loop on the outside, I do the column loop on the outside. And then instead of doing the column loop on the inside, I do the row loop on the inside. So these 2 loops are switched. Everything else, though, stays the same. Here's the biggest mistake I see when people want to do column major. They just try to switch these 2 things. Some people do like array sub call sub row. That is not column major. That is not how it works. We always, when we're subscripting our elements in a 2D array, do the row first, followed by the column second. If you want to loop over the columns instead of the rows, you just switch the loops. Don't switch the order of the indices. That is a huge blunder that I see all the time. I don't believe I wrote column major on here, so I'm going to write a column major loop really quick on top of this note sheet. I recommend you do the same thing. I'll try to make it short and to the point. If you want to do column major, aka columns first, columns up and down essentially, you would write your for loop to loop over the columns first. Do you guys want to use col or C? C it is. C is less than, I'm just going to use matrix as the name of my 2D array, sub 0 dot length, C++. And then inside of that, I would loop over the rows. So it might not seem like much, but all you're really doing if you want to go columns first, rows second, basically looping up and down instead of left to right, you just switch the two loops. I know many of you are writing it down. I appreciate it. Those of you that aren't writing it down, I hope it doesn't show up on free response day for you, and if it does, I hope you miraculously remember at least this moment where I told you to write it down. If you also remember how to do it, that would be great too. So basically the idea is if you want to go column major, up and down instead of left to right, you just switch the two loops. Dana, yes? Can you say it one more time? Sorry. I think for doing column major, I think it would be a little bit tricky because what is row? Because R is not defined on this first line. So I think you could possibly write a funky for loop to do this, but I think it would be absolutely insane if the College Board asked you to do column major and it was a ragged array. It would be insane. I think 99.9% sure everything's going to be rectangular, but you understand why you can't use row there. Okay. Okay, cool. Good questions. Any other questions? All right. We are about halfway through our material. I know it's a little bit early, but why don't we take our 2-minute break right now, and then we can come back and finish and talk about an enhanced for loop, stuff we didn't read over the weekend. So if you go to the Google Classroom, there is a link that's, how do you pronounce this? Quizzes? Quiz. Oh, exactly how it looks. Quizzes. How do we, okay, now I'll admit I did not write this one. How do we do a quizzes? Live, oh wait, I can host it and everybody plays? Like a Kahoot? No. All right. Well, I'm going to put my phone away so I can participate properly here. I guess I'll sign, oh, can I skip this for now? I don't want my results, I don't care. Host game. Do I just host game here? Whoa! Go to joinmyquiz.com and enter the game code 266436. Oh, Joel, I see you. Matthew, I see you. Annie, you're in there. Dana, thank you. Xander, thank you. Whoa, John, Ammon, Zach, Daniil, Jonathan, Miranda, Ethan, Mitchell, Noah's, yes, Noah's in there, all right. Dawson, Zoe, Spencer, Ian, Sam is in there. Holden, how many participants should we have? 3, 6, 9, 12, 15, 18, 21, 24, 27, 28. I'm waiting on a couple slackers. Sesame salt. Subaru, we got 26. I promise Subaru. We got 26. 3, 6, 9, 12, 15, 18, 21, 24, 27, 28. There's 2 holdouts. I will not tolerate slackers. 20. Thank you, Maya Abdallah. I wonder who it is. And who am I waiting on? Clay Curtis. What's going on? What? Wait. Have Mitchell help you. Have Sam help you. Mitchell, get on it. Just say skip for now. You don't need to sign in. I'm losing momentum. I'm losing steam, Clay Curtis. Let's go. All right, Clay, you are now on a team with Mitchell. You've been relegated. Clay, you and Mitchell are on a team. Oh, wait, 28 per Artichoke Athena? All right, I don't know. Maybe that's Clay. No? Okay. Clay, you and Mitchell are now on a team, or you can participate. All right, here we go. Is there music? Oh, no, that's my music. Well, I don't get to see a question? Teacher a monster? Why did you say that? Don't get tilted.
What is it? First to 13.
How do I know when the game is over? 20 on 20. No rush. No rush. Oh. Work quickly and destroy Annie.
Miranda, you're not
No, absolutely no rush. No, you just got to work on your actions per minute a little bit. You got to get that twitch. Maybe Annie's younger than you, so she's got faster hands. You could have been a contender. Artichoke Athena, let's go.
That's a real person.
Maybe it's just a random person trying to join our class. Alright, I'm giving you 30 seconds and then I'm ending the game, no offense. I don't know why people are saying it's Cooper. Cooper, hurry up! Wait, what? Oh, you're...
I took a random name, that's what came up.
If you're still playing, you got 20 seconds. Oh no! John, I'm so sorry. How do I end the game? Oh, results. Dana third. Noah second. Eddie Limo, get out of here. Nice job, nice job. Nice job to all the participants. And oh, a mastery party. Oh, Eli, Holden, Mitchell, Andy, Spencer, Jonathan, Miranda, Zoe, Daniil, Spencer, Ethan, Brent. Wait, is it going in both directions? I'm confused. What is this, row major? Is it column major? Help. Toughest question. Let's look at the, oh, great. Look at this accuracy, 91%. That's spectacular. Toughest question. We should look at this. What determines the order of traversal in a nested for loop? The outer for loop variable. Remember, the outer loop changes slower than the inner for loop. The outer for loop does not execute until the inner for loop is done with its job. So, I mean, but if our lowest accuracy is 86%, you know what? I'll take it. That's pretty good. That's pretty good. Our overall accuracy.
New quiz.
New quiz. All right. I'm not going to look at the results any further. I am going to move on, however, to the back of the note sheet and this next link, 8.2.4 enhanced for each loops. And I'm on the back of the note sheet as well. And I'm muting whatever music that was. Oh no, is the music from quizzes going to make it so I get ID matched on YouTube and they take my video down? I'm going to get demonetized. Oh no. But it's all I have. Copyright, darn. All right. We need to cover this second link here, enhanced for each loops. Okay, so enhanced for each loops are very, very common. Those enhanced loops, the one with the colon, are very, very common on the AP test in the multiple choice part for two-dimensional arrays. Remember that from the front of the note sheet, we already talked about how enhanced for loops work, but just a quick reminder, you always write for, and then in the parentheses, you do the type of elements your array contains, space, whatever you want to name your placeholder, colon, the name of the array. That's how it works for one-dimensional arrays. For two-dimensional arrays, it's a little bit more complicated. So here is a method to find an average using an enhanced for loop. I want you to pay close attention to that line 7. Line 7 says for each integer array, inner array in A. What does that mean? Well, let's keep in mind, what is an element in a two-dimensional array? An array. So on line 7, it's basically saying for each array in A. Then line 9 says pull out a value from that inner array. So if you look at this, let's say our row, let me go ahead and make a quick array here. Let's say the array looks something like this, 1, 2, 3, 4, 5, 6. This first for loop here will basically take this first row and set it equal to inner array. Then the inner for loop says loop through every single integer value. Notice there's no square brackets on line 9. Why is there no square brackets? Well, an element of the inner array is a int. So for this inner for loop, inner enhanced for loop, it'll basically pull out a single element and store it inside a val from the row or from the inner array. So 1 would get stored in val, then 2, then 3. That would be the end of the inner for loop. The outer for loop then would pick the next row, store it inside of inner array, and then the inner for loop would loop over the elements in that inner array. Sometimes when I write these, I do something like this. I call this row, and I call this element. Some people like that better because it says you're pulling out a row on line 7, and then on line 9 it says you're pulling out an element from that row. And then you would go ahead and just add every single element to the total. If you wanted to do that, maybe those variable names make more sense to you, I'm not sure. Here's the big thing that people struggle with. And a single element of a 2D array is a 1D array. So that outer for loop for an enhanced for loop should be pulling out 1D arrays at a time. The inner for loop pulls out elements of the 1D array, which are just single ints or strings or doubles or whatever. Yes, Eli?
Since the arrays are kind of made in row major, you wouldn't be able to do column major with enhanced for loop.
Absolutely correct. You cannot do column major with an enhanced for loop. That is a great point. It is impossible to do column major with an enhanced for loop. You can only do row major with an enhanced for loop. Great point. I've got a couple examples here of enhanced for loops on the back. In fact, I've translated some code with a regular for loop into an enhanced for loop. I want to make a few notes on here. To loop over the rows in a regular for loop, this is how you do it. To loop over the rows in an enhanced for loop, you do it something like this. This says pull out each one-dimensional array inside of the matrix and call it row array. To loop over the columns or the individual elements in a regular for loop, you do something like this here. And in enhanced for loop, you're pulling out elements from the row array you just created in the previous enhanced for loop. So you'll notice you pull out an element from the row array. Basically, this says for each one-dimensional array in the matrix, and then for each element in that one-dimensional array. And then lastly, to access an individual element, in a regular old for loop, we do matrix sub row sub call. In an enhanced for loop, we just say element. So what I have highlighted or underlined there, those are corresponding parts of regular for loop versus an enhanced for loop. We've been over it before. Will you ever have to write an enhanced for loop? No. Anything that you could do with enhanced for loop, you could also do with a regular for loop. Will you have to do multiple choice questions on an enhanced for loop? Absolutely. So making sure we understand it, specifically that first loop. It says when you pull out an element, that element is a 1D array. That's what the part underlined in blue means. You're pulling out a 1D array, and then from that 1D array, you can pull out individual elements. Questions there? Down below, I have something like summing all of the elements. It's very, very similar. You can see the corresponding parts. Again, I pull out an individual row, and then from that individual row, I pull out elements. So when you're writing enhanced for loops, this row that you create in the outer for loop must be used in the inner for loop. I pull out a row, and then I say I pull out elements from that row, essentially. So these two must be the same names here, because I'm pulling out a row, and then I pull out elements from that row. Let's see. This activity 1 here, it pulls out every single element. I wanted to, let me see. Do I want to add anything to it? If we add to it, we might be able to read it a little bit better. Val, yeah, we could do that. So for this one here, if I go ahead and I print out, let me just take it back to what it started with, like that. I can print out each individual value and kind of show you what's going on, maybe a little bit better. So I'll print out value in a space, and then after it goes through a row, I'll print out a new line here. So just to make things maybe a little bit more visually easy to understand, this pulls out, this loop, inner array right here, pulls out a row at a time, and then this inner for loop pulls out a value one after another after another. And same thing on the next row, one after another after another. So I just added in a print statement to print each individual element with the space. When I get done with the row, I just started a new line. So you can kind of see visually what's happening there. All right, let's do some of these together. 8.2.5 says 2D array algorithms. It says all of the array algorithms can be applied to 2D arrays too. For example, counting and searching algorithms work very similarly. The following code adds all of the values in a given row. So here we're given a row, we're given a two-dimensional array named A. We're also given a row number. And essentially we're supposed to add up all of the elements just in that individual row. So to do something like that, if the row is staying the same, for example, if I have an array like 1, 2, 3, 4, 5, 6, and I'm passed in this array for A, and then for row I'm passed in 0. That would mean I just want to add up these elements in the 0th row and return that value. Essentially what's going on in this case is I receive a parameter for the row, and all that's changing is the columns. I know we always think of processing two-dimensional arrays as two different for loops, but if the row is staying the same, I only need to look at the columns changing. You'll notice you only see one for loop here, because I add 1, then I add 2, then I add 3, all inside of the same row. You'll notice that row does not change. It's all the elements in the same row, so that's why there's only one for loop. Now it says, can you add another method that gets the total for a column? Let's go ahead and try to write that one together here. I'm going to write it right after get total for row. I'm going to write a new method, public static int get total for col. I'll take in a column, and I'll take in a 2D array. This lets you left brace enter and a right brace. Good stuff. I know the indentations are a little wonky. Don't worry about it. All right, so in this case, let's again use an example here. If I have 1, 2, 3, 4, 5, 6 as my 2D array, and let's say that's passed in for A. If I'm passed in column 0, I would want to add these two elements together to get 5. What's changing here, the column or the row? The row changes. These are in the same column, but they're in different rows here. So I'm going to need to write a for loop similar to this one, but instead of looping over the columns, I'm going to loop over the rows. I also need to keep track of a total, so I'll make a total variable. Note that this total variable is local to this method, different than this total variable, which only existed in get total for row. I'll go ahead and loop over the rows, since that's the thing that's actually changing. How do I get the row numbers? Or the amount of rows? A.length, very good. And basically what I want to add is every single element that's inside of that column. So I'll do total plus equals A sub row sub col. Even though I'm going column major order, I still keep it sub row sub col. The difference is when I loop over a column, the row number changes. When I loop over a column, when I loop over a column, let me try this again. When I loop over a column, a row number changes. When I loop over a row, the column number changes. So in this case, I'm looping over a column, so the row number is changing. Last thing I need to do, I think, is return the total. Method compiles, that's good. I'm going to call, so it should be the same total. No, it shouldn't be the same. It should be different. I'm going to call get total for col down here. And let's do adding these 0th columns together. Let's see if that works. It should be 5. Yes. If I change this number so it adds the 1th column together, that should be 2 plus 5. That would give me 7 if I change it to the 1th column. Indeed, 7. And so on and so forth. So the big idea is you might be asked to add up all the stuff in a single row. If you're adding up the stuff in a row, the column number changes. If you're adding up all the stuff in a single column, the row number changes down that column. Does that make sense? Okay. What's next on the agenda? Let's see here. You can loop through just part of a 2D array. You can change the starting value and ending value to loop through a subset of the 2D array. Oh my gosh. I'm going to skip that. We don't need to do that. You know, I think we're actually good here. I just want to say some things about the note sheet really quick before we move on. I do have an example of summing up all of the elements by column here, kind of similar to what we just looked at. So I did put that on there as well if you need to loop through the columns. Maybe you want to make a note to yourself that this would be kind of just going up and down a column, a single column, something like that. I have something about random shuffling, but I don't think that's important. Just swap some stuff in a 2D array if you're interested in that. All right. The last thing I wanted to do was write down the three types of loops together here. Let's do it. You ready? Here we go. Regular row major nested for loops. All right, for. I'm just going to write R instead of row due to space. Let's say that our array is named A, not Subaru. Sorry, it's tiny. You're going to have to write tiny. That'll loop over the row. Since it's row major, I want to do row first. Inside of that, I'll do columns. I can't just say a.length. I have to say something like a sub 0.length. C++. C++. And then to get a single element, I do A sub R sub C will be a single element for a regular old row major nested for loop. That's the first one we want to know. That's the most common one you use. You want to count the number of even numbers. You want to do something like that. You want to find the position of something. You can use a regular old row major nested for loop. What if you want to go up and down the columns? You're asked to sum up a column for whatever reason. Then you can write a column major, and basically all you're doing is switching these two loops. So I can do something like for int c equals 0. C is less than. Now here's the tricky part. Since I'm looping over the columns, I'm going to make this bound a sub 0 dot length and go over C++. Then I'll go ahead and loop over the rows. And then just the same thing to get a single element, I do A sub R sub C. Even though I'm doing column major order, the only way that the only thing that you have to change to do column major order is you just switch the two loops. You do the column loop on the outside, the row loop on the inside if you want to do column major. Just basically think which is it row major? Do I want to go left to right, then do the row loop on the outside? Do I want to go up and down? Then I'm going to do the column loop on the outside. The last thing, enhanced for loops. I'll just do this in row major format. I'll say something like for each integer array. I like to call it row. No. You guys will get confused if I call it row. For each integer array. What should we call a single 1D array? They called it inner array in the example. If I don't like to call it row because then you guys will get confused with the row index. Inner array? I don't know. You're pulling out an inner array from the 2D array. This says pull out a single row, which is a one-dimensional array. Then from that one-dimensional array, let's say it contains integers, you would do int, like element, inside of the inner array. And then if you want to see a single element, it's just going to be named element here. So regular old for loops, row major, column major, enhanced for loops in row major format. You got a little bit of all of it. It's all there. Questions? Okay. All right. Yeah.
Is there any like practice like this on like coding that or practice it or anything like that?
I got these. There's the stuff that's built in right in CS Awesome there. There's 1D arrays. I want to say that Coding Bat does not have 2D arrays. It only has 1D array practice. But maybe you want to practice doing some 1D array stuff. You could do that because 1D array stuff is very similar to 2D arrays. It's just how many loops are you using. So you could do 1D array practice on. We're going to do 2D array practice though. What's coming around is a sheet that has some 2D array practice. They're coming. I tried to make a little sheet where you could practice writing your loops and writing some methods. We could all use some help writing loops and methods there. It looks like this. The first one says count it will return the number of times that val occurs in math. So basically you're looking for some value inside of a two-dimensional array. Every time you see it, you increment some counter there. So that's what's going on in the first one. The second one says count odds. Count odds will return the number of odd numbers that exist in the two-dimensional array map. So you're counting up how many numbers are odd. How do you see if a number is odd? Well, just keep in mind if you do some element r sub r sub c, if it's odd, when you take mod 2, it will not be equal to 0. That would determine that a number is odd. So you're counting the number of odd elements. The third one says complete max. Max will return the maximum value in the 2D integer array map. So you're finding the largest value, something like that. The fourth one is square. Will return true if all the rows in the 2D array map have the same length. Otherwise it's false. So basically if it's a ragged array, you're going to return false. If they're all the same size, you return true. Row sum. Hey guys, we just did row sum. It's like on the CS Awesome site. So we just did row sum. So wink wink, nudge nudge. 5 should be easy peasy. Number 6, complete the method call sums. Okay, this one's a little tricky. Call sums will return a one-dimensional array of integers where each ith element represents the sum of the elements in column I. For example, the element at index 2 in the returned array will represent, why is there an error there? Will represent the sum of the elements in column, this should say column 2. Oh my gosh, I made a boo-boo. This should say column 2 on the back, sorry. Don't judge me. Oh geez, no wonder people are only watching 1 second of my YouTube videos. Alright. So in the last one, you're actually going to make a one-dimensional array that has the same number of elements as there are columns. Assume it's rectangular, and you'll return an array that contains the sum of every column. Kind of like a spreadsheet, basically. You have the rest of the time to do this if you want to work alone. If you want to work with a partner for at least the few minutes that you're in here, I don't care. But I figure we could use some practice. And so this is practice. This is your homework. We will check it tomorrow.